Okay, today this course is particularly helpful for those who completed their civil engineering or who is having interest in the transportation engineering who wants to pursue this transportation engineering in the future. Uh, okay, means transportation engineering has various branches. If you have interest, you can develop your career in the payment, you can develop in the traffic, and even you can develop in the geometric design. Being a geometric designer, I feel working in this environment is very resourceful, and you can gain a lot of knowledge. At the same time, it is very interesting also because in the geometric design, normally you will be dealing with the roadway geometrics. Means in our plus one or plus two, you might have came across geometrics like means heights and distances, those all. So basically, we'll be using advanced geometry of those applications and how we can use that in our road construction. Means how we can place our curves, our tangents. These all will be focused. Okay, there will be certain softwares which are helpful to do to make the design. Okay, so I'm calling this as a geometric design of highways because design of highways includes various other aspects such as pavement design. Okay, if you normally when you are going on a road, you might even observe bridges, right? So we have separate department even for the bridges. They will design those bridges. So they call it as a bridge design of highways. So we, the highway engineers, we are the like the apex of this highway design. Means normally we do the design a lot. So we have to coordinate with other teams, get the inputs from other teams, and we have to implement in our software. So it is a very beautiful process where you can engage yourself, you can involve in yourself into the design process. So today I'm going to just brief you about importance of geometric design, how you can be get interest in that, what are the elements that are included in the. So this all, it is a just basic level focus I am trying to give in this 45 minutes. So after this webinar, I think you'll have some amount of knowledge, means what are the aspects that are involved in the highway design. So you can take it forward if you are having interest in this particular field. You can always grow more, right? Okay. Uh, in this presentation, I'm going to present you about the introduction, means overall top view of the highway geometric design, where what are the important things you need to focus on that comes in the objectives. What are your primary things that you always have to keep in mind while you are designing. Being a highway designer, you always have to keep some particular elements always in consideration, no matter what. Those all will be coming under the objectives and the factors of the geometric design. The factors means what are the things that are in the highway design. Say, for example, speed and other roadway cross-section elements and all, how they are impacting or how that will have an impact on decision making of a geometric designer. Means in overall, geometric design is a very vast subject. So means you cannot confine all those factors which are influencing the geometric design, because each project has different types of factors, okay, and miscellaneous factors as well that will be impacting your highway design. So I'll be focusing on most common factors that will influence the geometric design and the cross-section elements. Uh, okay, don't worry if you have never heard about this terminology now. Yeah, but by the end of this presentation, I'm sure you'll gain so much knowledge in this. So, cross-section elements means for if you are traveling on a road, imagine median. Median is a cross-section element, and beside the lanes, these are cross-section elements. So, what are the general cross-section elements? How we take those into consideration while designing? Those all I'll just give a glimpse in the cross-sectional elements. Coming to horizontal and vertical elements, here how the horizontal geometry is considered means while designing a road, first and foremost thing is to fix the horizontal alignment. Okay, after doing the basic survey, as a designer, do the horizontal alignment means what are the factors that are affecting the horizontal alignment, and also what is horizontal alignment, what is horizontal alignment. Those things I'll be just teaching you over here. And vertical alignment is a means horizontal means when you are running on the road. Okay, if you see from the top how the road looks like, that is typically the horizontal element. Uh, Similarly, when you cut the road vertically, means lateral, then you see the long along the road. If you cut the road longitudinally, then what you see there is a vertical alignment. So, what are the terms and terminology which you use both in horizontal and vertical alignment? We'll be discussing soon. Okay, you can ask any questions at the QA session. Coming to the geometry, you see this beautiful road here, right? When you see this road, you might get an impression that this road is a bit zigzag, right? Why can't we build a straight road instead of building a zigzag road? You will get that answer very shortly when we are discussing the factors of the highway design. Okay, and in the geometric design, it may we focuses mainly on the dimensions of the uh, road geometry. Means we have to fit our road in the available land. So you cannot go everywhere you want. Okay, you cannot take the alignment means whichever you want. See, if you see, if we imagine some places like Hyderabad and Bangalore, okay, cannot directly join these two lines and I say I can build the road in a straight line. You have to follow certain things which are beneficial to the places which are in between. Okay, like if you are going from Hyderabad to Bangalore, you will come across Karnool, you will come across some other place. So you have to join those places and you have to follow some means you cannot go straight lines, means you have to between villages, and even you have to follow some certain specifications which are mentioned in our IRC, means Indian Road Congress for Indians, and these kind of manuals will be there for every country. So in those manuals, you will come across different things like how many trees should be planted, what are the drainage, how to provide drainage considerations along the road. So we have to satisfy each and every department, each and every vertical while working on a geometric design. So what should be your focus? What should be your main objectives while designing a highway or even a municipal road? See, your first and foremost objective is to have safety first. Means in a recent article, our Nitin Gadkari also mentioned that most of the 50% of the accidents are caused by the design blunders. Means while designing itself, if you are having and if you can convince the contractors or somebody who are constructing the road with the right attitude, means you can there and there itself you can minimize the 50% of the accidents which are happening on the on an year. So this is what point and the analysis which he brought. This is very sad that means although it is very sad, it gives a lot of opportunities in this vertical. Means you always can excel and there is always scope for improvement of your highway design. So optimum efficiency means you are, as I told you before, if you are building a road from Hyderabad to Bangalore, it should not means your main focus is not building a road from Hyderabad and Bangalore. You have to connect in between villages like means or cities like Karnool, those all. Means if you are building a road, means the people along the corridor should get benefited from it. Okay, and providing comfort means imagine when you are traveling on a road, you might be feeling some bumps. Okay, your vehicle might be, you might hear some noise, right? Especially when you are going on a cement road. So these all are practical issues. How you can means, if your geometry is good, means if your riding quality is good, means if you are following the road geometrics in both horizontal and vertical, you no doubt what it is, your comfort is always going to be good. You might always already has felt that if you are traveling on a certain roads, yeah, this road is very good. And when you travel on other places, then you might feel, why am I feeling so much of noise? So it is because of the small bumps in the vertical geometry in particular. That is what it is causing. Or even the type of the materials they use by constructing the road, even that affects this comfort. And within a reasonable cost, it means you always have to try to build the road in a thinking of a green perspective, which means you have to use recyclable waste from thermals. Means while constructing a road, I think you all have this basic knowledge. Like while constructing a road, first we build subgrade, which comprises of the earth material, then GSP, then comes asphalt layers. So at all these layers, there are some alternate materials which you can use. When you use those materials from the nearby places, then you can certainly reduce the cost. And even using the available government land, okay, making the road pass through the barren land instead of agricultural land, if possible. So these are all the cost cuttings which you can do. So our, as a designer, mine or the person who is designing a road, their main prospect will be the safety, efficiency, comfort, and cost. These are the main things which you have to focus no matter what while designing. Coming to the factors that affect the roadway design, there are numerous factors as I told you. See, the first is the design speed. Think a certain road, a free road means if you are traveling on a highway, the design speed is 100. If you are traveling on a local road, the design speed is 60. How does this design speed affect the geometry design? You might wonder, right? So when you're traveling on a highway, I mean on a free road, then the curve radius is more. Okay, imagine if you are at the intersection, approaching the intersection, and you want to make an U-turn. Okay, so while making an U-turn, you obviously reduce your speed. So when you reduce your speed, okay, then you can turn your vehicle in a small radius, right? So this is what happens. If you are traveling at a 100-kilometer speed, the radius is going to be a large. So that is what it is impacting the design there. So that different types of speeds, okay, will be having different types of radius and different types of super elevations. These are all interrelated, and you have to be very specific while picking it. Okay, so obviously even this design speed can impact on your travel time, okay, and even the safety in some conditions. Means if you are designing on your a particular road at 60 kmph, say, and you are traveling at 100 kmph, then it is not advisable, right? So you might design those curves, everything, that side distance for that particular design speed is designed for a less speed. But when you are traveling at a higher speed, there is always a probability of getting an accident, right? So you should be very careful. So as a designer, we always design on a safer side. So if you say a highway is designed for a 100 kmph, so we keep in mind that it is going to take 120 kmph, but not like you are not an F1 racer, right? So you cannot go on that road at a 200 kmph speed. So obviously there are more chances for an accident. And topography, in the previous slide you saw this, right? Why can't a road can be built straight? If you see this, I would like to just zoom in this. Okay, see, if you see these values, okay, here I hope you can see these values now. This is 560, this is 530. Means what are these values? This is a topographical map. Means 530 means the elevation on this entire contour line is 530. 560 means for this entire line, it is 560. Okay. So this is 580. So these are the elevation lines. Means if this is Hyderabad and if this is Bangalore, you cannot build a road straight, as I told you, just because see here the elevation is 530, 520, 560. So you will be changing lot of topographical lines. Means you, while constructing the road, you have to cut so much of material or even fill this so much of material. So the best way is, yeah, although the road is bit long, okay, the best way is, see, you take some line like 530 line. Okay, see, if you construct the road along this line 530 line, then your elevation will be the same. Means you'll not going up the hill or down the hill, so you will find the most flattened road. So whenever you want to change from 530 to 560, suppose from here I want to change to 530 to 560, so I will design a smooth tangent, so you'll not feel the bump. So while you are traversing from 530, slowly you will change your direction and you'll merge with the 560 lane, and slowly you'll merge with the next, and this is how we connect the cities. Normally, this is, if you are going in this way, this is a guard road. Means if you don't have any other constraints, like then this will be, obviously you can understand the hilly roads, right? These are the very specific and design technology we use, and for the road function is also will be served for only one purpose, just to travel from one point to another point, and it is not at all cost effective, but we do that on demand, right? Okay, so this is the how the topography of a land, means the surroundings around us will influence the highway design. Even the vehicular characteristics, you see our roads are too much crowded, and most of the time the traffic is always there. Just to say you, the urban roads are not designed in India, so that's why you feel this type of traffic overflows. Normally we only have traffic, we only address the issues that are caused in the traffic perspective. So that too means signalized intersection, or you want to have an at-grade intersection at some places, but normally definitely the road width at this location is not sufficient. So you can see that this road width means there are so many vehicles that this road width cannot accommodate those vehicles. This is the primary reason why you are getting. So either you have to create some other upgrade, means a flyover, I mean upgrade section we call it, a flyover here, or you have to divert some traffic. So these are the vehicle characteristics. See, if you see the vehicle, can you anyone imagine how this weight of the vehicle can affect the horizontal or the geometric design? See, the weight of the vehicle will affect the total load of the pavement should take, right? So the pavement engineers will do certain calculations, and they'll use some crust thickness. So that we have, as a geometric designer, we have to take inputs from that department, and we have to introduce in our design. So when you do that, your design, your ultimate goal is to give cross sections, means which I'll be showing the future slides. So cross section is the ultimate thing we, as a designer, we give for the contractor to build a road. So these are the very interrelated things. Okay, even the human characteristics, means, okay, in the civil engineering, most of the people have studied about the PIEV theory, means where if you are approaching an abstraction, then your mind will take some time to process it, to find that there is an abstraction in front of us. So that distance is called braking distance, and the distance after applying the brakes and the time taken to travel. So after applying the brakes to reach the obstruction is called lagging distance. So this complete distance is called stopping side distance, which will be considering while doing the design. Means at any point of time, you should be able to see an object while designing a road. Means if you are designing a road, your normal height is considered to be a 1.2 meter, and you have to see the 15 centimeter object at any point of time. That is one of the basic criteria while designing the road. There are other factors like noise pollution and sound pollution. Oh, come on, how does noise pollution and sound pollution can affect the geometry design? Okay, if you are designing a road, okay, in an urban area, your horns, okay, your pollution, your noise pollution might affect the residents who are beside the road, right? So for that, we construct certain barriers. We call them as the noise barriers, where those noise barriers will not make pass our sound to the other side of the road. So this way we can include those kind of elements in our cross section, and we can even design. Okay, and the as I told you, economy, it is a self-explanatory thing. You have to be always design your road, okay, at the very minimal cost. It means economy in terms of geometric design is you have to minimize the earthworks. Okay, means the amount of granular or even the asphalt layers which you provide in a road construction, that is very similar, but the earthworks will vary depend on your profile. So when you optimize your profile, you can reduce the economy of the project. So as a designer, you can do a lot towards economy of the project. And drainage constraints. You see, most of the Indian roads are not addressing this issue, and means I accept that highway roads are being addressing this issue, so you will not find any water logging in the highways. If you find also, it is only on the very minimal conditions, I guess. But in the urban roads, you see whenever a flood comes or even a rain comes, you normally have a lot of water on the road. Do you know why? Because we don't have a proper drainage system. That is one thing, and other thing is we might be in a low-lying area. So actually, as a designer, you have to you are responsible. If a water droplet falls on the road, how it is traversing, means to which direction, to which culvert it is going, to which stream it is merging. You should have that much of confidence that where this water is going. So water is the first enemy of the road because it can destroy you completely. And even the property limits. You see, yeah, as an engineer, you might feel this is a funny because these temples or even the marks, they could be anywhere, even on the road. So these are means you have to protect this. At the same time, these are not advisable to be on the road, especially in between the lanes, right? So you have your geometry should be precise. This is of course, a design failure, but I think you cannot help it here because of the property constraints. People means if you just want to avoid this, okay, and you have to if you want to avoid this, your horizontal design is going to be affected for more than 1 kilometer. Means that is how it is going to affect. If you just move this center line towards the right side, then all the geometry after that and the before that will get disturbed. So there will be a lot of property acquisition should takes place. So in an urban situation, I don't think so that could be possible. So that is why some people might have simply constructed this road, even though it is a technical failure. In terms of geometric design, they might not help it because of the governments and all other issues. So as a designer, you have to be, means it is your responsibility to protect the means mosques or temples, which are the landmark for the religion things. So you have to protect that, and at the same time, you have to give a good safety geometric designed roads. So that is your aim as well. That should be your aim. Okay, and if you see, there will be a underground systems under our road. Means our road is the free property for all other departments. See, if it is a stormwater, or even the stormwater means, you know that wherever rainwater falls on the road, how they are catching, how we are transporting this water from the road to the other channels or even the streams, how we are transporting that. Normally, we transport all those water through stormwater drains, we call it. And normally, we have some catch basins here. I'll show in the next slide if they have. You might have observed, means there will be a steel grill on the road, right? So these are the catch basins. Means when a water droplet falls on the road, the water should be going into the catch basin. So the catch basin means, in this road, the catch basin must be somewhere here, and they'll be having a pipe, and they'll connect to the stormwater, and this stormwater may connect to the nearby streams or wherever they want, okay, or the ponds, okay. And even you might be having the water mains, water distribution system. Most of the water distribution system will be under roads. This is also one of the prime factor, that once you design the roads, especially urban roads, it is not going to be a simple when you want to upgrade or reconstruct it, because it is going to affect many other departments. Okay, now if you see a particular road is drained because of water, okay, and as an engineer you might have recommended it to reconstruct it, to raise its level or lower its level. So when when the people or the contractors want to construct that road, if they dig the road, these all items are going to break down. So this is going to be a problem. Means the sudden breakage of water, where means they have to get in touch with the other departments, and so it is very important. I'm explaining all because it is very important. While initial, when you are designing itself, you should have the sufficient depth from the top of this upgrade to the top of this or invert of this stormwater or water main. So these are the things which basically govern you while designing the road. Okay. Okay. Let us go to the cross-section elements. You see here, this is a normal typical road. Means if you cut the road laterally, these are the things which you see, right? You see a median here. Here you might not see it, but it is a median. And this is a lanes where vehicles travel. Okay, this is in foreign conditions. They provide separate cycle track. Even in some parts of Ahmedabad, we are having these types of construction. So where only we means the reason why they have mentioned this means they can simply say the same type of road, and we can just this only bikes will travel there. Means when they say bike lane, the thickness of the layers beneath the bike lane may change, because it is they expect buses not going through the bike lane, right? So bike lane, in a way, it accommodates only less duty vehicles. Means the weight of the vehicles which are traveling on the bike lane will be bit obviously less, so the thickness of this may vary. And you have the curb here, and the side, you don't have the sidewalk here, and this is a boulevard. Means where this is a green space where the trees are planted here, and we have the sidewalk. This is a typical, and it might vary from project to project as well. Okay, some people have the street lighting here. In our Indian cases, here street lighting on the median, street lighting. Those all can be a part of a cross section. So this is a typical cross section, just to understand you that the elements will be there in a cross section. So if you see here, this is a bike lane. Okay, in this case, I suppose they are all equal. They are expecting this vehicle also to travel here. If they want to provide a separate bike lane, they might give a separate curb here, means separate, and they will just differentiate the main lane traffic and the bike lane traffic, so that they can easily construct this with a different thickness and this with a different thickness. And coming to the side distance, okay. As I told you, what is the side distance? What is the side distance? We have to check the side distance both in horizontal and in the vertical. Okay, just imagine if you are traveling on a road. Okay, then you have to see a particular obstacle at a certain distance. If you are traveling at 100 kmph, see, as I told you, like side distance is having both the braking distance and lagging distance. You have to calculate all this. Then you will get certain amount of distance. Say for 100 kmph, the side distance is 250 meters. Okay. So at any point of the road, when you stand on the road, you should be able to see 250 meters along the road. Then only we say that it has addressed the side distance issue. What are the things that can affect our side distance? Some issues will be the profile things, means, okay, I'll just see if you are, although it is, see, in this location, if you see, this is an horizontal, you cannot, this is a straight line. If you see from the top, you see it as a straight line. But here, the vehicle you are not able to see because of the profile updation. So you have to raise your profile a bit so that you will not see this type of kinks on road. It is hazardous to the vehicles who are traveling on the road, right? And you also have to address overtaking side distance at some certain points of locations. Means you might not be able to give the overtake side distance at all points of time, because it is like 1 kilometer, or it varies from even 700 meters, 600 meters. So if you are having this distance, means you might be having some cause, other things. So normally we provide these overtaking zones on the tangents, particularly on this type of locations where you see a straight line. Okay. So what are overtaking zones means, how we calculate the overtaking side distance means, you should, if you are, say, sitting in a back car, you should guess, means there it will, you'll be having some time to react that I have to overtake this vehicle for your decision making. Once you do the decision making, you travel certain amount of distance parallel with the car, and you raise your speed, and by the time you even have to give some preference to the vehicles which are coming towards you, so on the other lane, opposite direction. So all these factors you have to consider, and you have to measure the distance. This normally will be like 5 times or even 6 times in some cases of the SST. If your SST is like 200, this will be like 1 kilometer, 800, something like that. And the intermediate side distance is like when you cannot provide even OSD, at least you should provide some intermediate side distance, okay, where you can overtake the slow moving vehicles. And coming to the headlight side distance, headlight side distance is particularly calculated in the SAC curves. If you are in this location, if you imagine, if you are going on towards the valley curve, so on this type of curve, during night times, your light will be projected only to the certain amount of distance. So that is called headlight side distance. Even that headlight side distance should be more or equal to the stopping side distance. Else, means stopping side distance is the minimum thing. That is the minimum criteria for any side distance that has to be addressed. Horizontal alignment. Yeah, I think we are almost towards the end of this presentation, I guess. Okay, we have two more topics like horizontal alignment. Horizontal alignment, it is just a top view of the geometric design or a highway design. When you are seeing from the top, okay, although here you feel like it is a straight line or it is a curve, but when you see the profile, it could be a sag or crust. Means you just have to imagine yourself, right? When you're traveling on a road, even on a straight line, you might go down and you might come up, right? So those are sag and crust curves. So coming to the horizontal alignment, normally we fix as a designer, you will fix the horizontal alignment. How do you fix the horizontal alignment? With the help of tangents, spirals, and even the curves, right? Normally we identify the straight sections first, okay? Here and suppose here straight section, here is a straight section, and we join those deflection with a curve. So you should not have certain amount of deflection, right? You cannot design a road like perpendicular. You have to give a curve so that the vehicle can maintain the design speed, and you have to give the super elevation as well. I think most of you know about the super elevation. Super elevation is what is super elevation? It is raising the outer edge with respect to the inner edge, just to counteract the centrifugal force. So this type of the super elevation will be provided at the curves. That is also the part of the horizontal element. These can be done in very easily. Means if you have the concept, software can do that for you. Means the concept and the calculations that is you have to gain from your basic fundamental skills. I think it should not be difficult. If you have any questions about that, you can always ask me. I can explain you detail over that. And the vertical alignment. I mean, once you are done with the horizontal alignment, you have to do the vertical alignment. Uh, Vertical alignment is basically a combination of crust and sag curves. Means we'll be having a k value. Means k is equal to L by A. Means it is the ratio of the length to the difference in the grade. Means if you are satisfying this k value, then automatically the side distance will be addressed. So for a particular design speed, you should have this the k means the k value is also referred as the smoothness of the curve. Higher the k value, smoother the curve will become. If smoother the curve, you can see the more distance. If more distance is there, the side distance is addressed. If side distance is addressed, you have done a good job in vertical alignment. So it depends on the amount of speed which you are traveling. If you are traveling so fast, you want to see a long distance, because within a small amount of time you are going to cover a longer distance, right? So at that time the curve should be flatter. If you are traveling at 20 kmph, like a street road, the road which is in front of your home, okay, so you might not need a flat curve. You can follow the topography and you can simply go up and come, because speed is not the criteria at the local roads. So you have to be very particular about the design speed and the type of the road which you are designing to address these kind of issues. Once you are done with the horizontal and vertical, you have to fix these types of cross sections project wise. It will vary from project to project. And once you are done with the cross sections, you will be doing the modeling and you will be taking out the cross sections and quantities. It means, yes, although this process seems very easy, there will be a lot of constraints and means as a highway engineer, you have to take considerations from the drainage team, from the structures team. Means they will give the bridge elevations. You have to match that. Drainage people will say the drainage profile will be should be this much below the ground. We have to match that. So all these issues are to be addressed while making a design. So there are some types of softwares like Civil 3D where this modeling can be done. if you are having any interest, I can even walk through in the future over the Civil 3D as well.